In this video, we will be solving exercise set 3.1 of class 9th. Let's start with the first question. So, in first question, a merchant in port city of Lothal is exchanging bags of spice for copper ingots. He receives 15 ingots for every 2 bags of spice. If he brings 12 bags of spices to the market, how many copper ingots he will get? Okay, so let's write the given first. So, if he gives 15 ingots, I stands for ingots, he gets 2 bags of spices. B stands for bags of spices. So, for 1 bag, how many ingots he will get? So, for 15, he gets 2, right? So, just divide on both sides by 2. So, for 1 bag of spice, he gets 7.5 ingots, right? So, now the question asks, if he has 12 bags of spices, how many ingots he'll get? So, for 1 bag, he gets 7.5. So, for the next bag, he gets 7.5. And so on till 12. So, basically, 12 into 7.5. For each bag, he gets 7.5 ingots. So, total will be 90 ingots. So, the answer to the question is, for 12 bags of spice, he will get 90 copper ingots. Let's move to the next question.
So, question 2 is, look at the sequence of number on one column of the Ishangu bone, 11, 13, 17, 19. What do these numbers have in common? List the next 3 numbers that fit their pattern. Okay. So, basically these are the 4 given numbers. And what can we observe from this? So, we can take the first number first, 11. Okay. So basically this is a prime number. What does prime number mean? Prime number means this number is only divisible by 1 and by itself, which is 11. It is not divisible by any other number. So how can we find that? Take leave 1 and take the remaining numbers 2, 3, 4 till 10. Don't include 11 since it is divisible by its own number. And try dividing it by each number. Take 2 and divide 11. If you take 2 and divide it by 11, you will get the answer in decimal, which means it is not perfectly divisible. Or in other words, you will get a remainder. Remainder here will be 1. If you take 3 and you take divided by 11, you will get a remainder as 2. Okay, these are not actual 11 by 2, it's the remainders. Similarly, even you can try taking 10. 11 by 10, its remainder it will be 1. So, no number other than 1 and 11 itself will divide 11. Similarly, it's the same for 13, 17 and 19. You can try it for yourself. You can take numbers less than that. Just leave 1 and take like 2, 3, 4 till 12 and nothing will be divisible by, nothing will divide 13. So that's what prime number is all about. So they are asking for the next 3 numbers that will fit the pattern. So you will find the next 3 numbers here. So basically all the even numbers are out. Why? 20, 22, 24 all are out. Because all even numbers are divisible by 2. So if they are divisible by 2, they are not prime numbers, right? They are called composite numbers. So what else is there? So let's take 21, 23, 25, 27 and 29. Now take 21. First try dividing it by 2. It is not divisible by 2 since it is an odd number. Now try dividing it by 3. So 21 divided by 3 will give you 7. So yeah, it is divisible by 3. So it is not a prime number. It is a composite number. So this is not a prime number. Take 25. Try dividing it by 5. So 25 by 5 will be 5. So this is also not a prime number. Take 27. Divided by 3. You will get 9. So this is also not a prime number. So the remaining are 23. 23 is not divisible by any number other than 1 and 23. So this is a prime number. Take 29. 29 is also not divisible by any other any other number other than 1 and itself. So this is also not a prime number. Sorry, this is also a prime number. So now take 31. Since 30 is an even number, we are skipping that. So if you take 31, you can try dividing it by any numbers other than 1 and 31 and it won't be divisible. So it is also a prime number. So to answer the question, the next three numbers are 23, 29 and 31. So let's move on to the next question. We know that natural numbers are closed under addition, which means the sum of any two natural number is always a natural number. Are they closed under subtraction? Provide a couple of examples to justify your answer. Okay. So basically natural numbers. Question 3. Natural numbers. First of all, what are they? They start from 1, 2, 3 and all other integers till infinity basically. Okay, so these are natural numbers. Now natural numbers are closed under addition. What does that mean? Take any two natural number, for example, like 11 and 17. If you add those, you get what? 11 plus 17 is what? 28. So this is a natural number. You take 25 plus 30, you get 55. This is a natural number. So similarly, you can take any two natural numbers, even same numbers, 25 plus 25 is 50. This is also a natural number. So you can take any two natural numbers and you will get the answer is natural number. So this is basically what natural numbers are closed under addition mean. Now they are asking, are they closed under subtraction too? Is what they are asking. So you can take any numbers first of all, like 11 and minus 9, you get 2. Okay, it satisfies. So 25 minus 20 is 5. Okay, it is satisfied. But just because some examples are satisfying doesn't mean the condition is true. All examples should satisfy for the condition to be true. Now let's take 20 minus 25 instead. 20 minus 25 is minus 5. So minus 5 is not a natural number. Similarly, you can take 17 minus 35. You will get minus 18. So that is also not a natural number. So if you subtract a smaller natural number, by a bigger natural number, you get a negative integer. So these negative integers, they are not natural number. So they are not closed under subtraction. So also we have provided a couple of examples. Fourth question is like a bonus question. So still let's do it. Ancient Indians used the joints of their fingers to count, a practice still seen in India. Each finger has 3 joints and the thumb is used to count them. So how many can you count on one hand, and how does this relate to the ancient base 12 counting system? So let's first answer till this, then we'll go on to the next question. Here is an image to visualize. So this is the thumb. So it is used to count, and here you can see the fingers. So let's count together. So this is 1, so this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically these lines are there, right? These lines are called the joints. So these lines are used to count. So in one hand you have 12 joints. So you can count till 12 using one hand. You are ignoring the thumb since it is used to count. So let's answer the next part of the question. How does this relate to the ancient base 12 counting system? So in the ancient system, before we moved to this like modern counting system, which is 10 it is called as decimal system. It is mainly used in sets of 10, right? So 0 to 10, then we move to the next one, 11 to 20, like that. So this 10 finger 10 decimal system came majorly due to the fact that we have 10 fingers in our hand, so it is easy to count. So that's why this became the modern thing. So this 12 joint was used in ancient times. So the main idea was that we had 12 joints in our hand and our thumb was used to count them. So this can still be seen today. Like if you look around, you will get a basic idea. So 12 inches is 1 foot. And how many months are there in a year? So 12 months in 1 year. And if you look at the clock, it will have 12 hours, right? 12 hours. So this is how it basically came to. Initially in the ancient India, we used our joints to count. So there were 12. So it was 12 base system. Then later on, we moved on to using our fingers. So we have 10 fingers in our hands. So then we moved to 10 base contact system, which is basically decimal system, right? So that's it. 4 interesting questions. I hope you understood. And that's it. Thank you.